Hi and welcome back to the channel. This video is a worked example using CESMM4 to take off quantities and produce a bill of quantities for a civil engineering structure. Now clearly there is a lot to learn about CESMM4 and we can't cover it in this single video, but this will give you the basics of site clearance, excavations, formwork and reinforced concrete measurement. So let's get going. The structure that we're going to use to show how we can take off and produce a simple bill using civil engineering standard method of measurement is this structure here. It's the foundations for a travelling crane. It's a fairly simple structure. It's got 8 bases and it's got 10 cross beams. So it shouldn't be too difficult to be able to quantify and produce this simple bill. I think one good thing about today's drawing packages like Revit is that you can actually produce 3D views, and I always think that's a good idea before we start to take off quantities in civil engineering, is to have a look at what it looks like. It doesn't need to have any dimensions, but it gives you a feel for what it is and allows you to see things that you wouldn't necessarily see straight away when you're using floor plans and sections. So let's give it a go. Before we do any taking off, it's always a good idea, indeed it's essential, that we peruse the drawings that we are going to use so that we can get a better understanding of the layout and the overall dimensions. So what we're looking at here is the plan view of the bases. This is drawing number A103. It's not immediately obvious because this is scanned straight from Revit itself. But if you've had more formally issued drawings, it would be really important to check the revision number and log those in some way. So we have our principal dimensions. We've got 8 meters, 8 meters, 8 meters, 8 meters. So the center line to center line to center line is 8 meters in both the length and the width. We have the base sizes, that's 2 meters by 2 meters, and we've got the beam width of 0.5 meters, 500 millimeters. Importantly, we have our EGLs, existing ground levels, and these are different. So 17.65, 18.00, 17.85 and 17.6. So clearly we'll need to take those into account when we move on to the excavation class within civil engineering standard method of measurement number 4. We also have some sections. We've got a section 1 here looking in that direction, and we've got a section here looking in that direction. And those will be 2 additional drawings which we will have a look at in a few moments. So I think that's probably all we need to take in from this drawing at this moment. So let's move on to the sections. This is section 1, which is from the south looking north. Now let me just see if I can explain that a bit better. This is our plan view that we've just been looking at. This would be north, east, south and west. So our section 1 is this one here looking in that direction. So what can we see? Well, first of all, it's referred to as A104. So again, that's not obvious from this sketch, but from Revit itself, that's the sheet number A104. We have an indication that the EGL varies, which is good. So there is a sort of an arbitrary existing ground level along the top here. But the important things to look at are the levels down this left-hand side here, because these are the ones that we're going to use to measure from. So the first one is the top level of the base, which is here, and that would run all the way across all of the bases, top of bases, 17.4. The next one is the underside of the ground beams. So these are the beams here that you can see. So this level here is the underside of all the ground beams. And the next one down is the underside of the intermediate bases. So that suggests that the intermediate bases are not as deep. And if we look at the drawing here, we can see this is our corner base. And here we have one of the intermediate bases. And you can see here that this level is shorter than this level here. And then the last one is the underside of the corner bases, which is 16.00. And as you would expect, it runs along the bottom there all the way across the site. So that's the important takeaways from this drawing. We also have a reference to a section. So we will look at section number 2, which is labelled as A105. So let's have a look at that one. This is section 2 and it is eastwards looking west. So just let's look at the plan. So this is section 2 looking in this direction, so we will be able to see the two corner bases. It's labelled A105 and we get the existing ground level varies note up here, so we could see the existing ground level here, which varies of course. The important information is here on the left hand side. So we've got top of bases again, which is 17.4. It's bases, so it's all the bases in the structure. We have the underside of the ground beams again. So here are the ground beams at 16.95. Then we have the underside of the interior bases, internal bases, which is 16.2. Now we can't see those in this section. We can only see those in section 1. But nonetheless, the level is there. And then finally, we have the underside of the corner bases, which is 16.00, and we have the line here. So I think that's probably all the information we can glean from this section. So let's now move on to look at our first takeoff sheet. Okay, let's have a look at our dim sheet, which does look rather complicated. I've attached it to the drawings, to the plan here, so we can see where some of the numbers come from. But don't worry about its apparent complexity. We're going to go through all the numbers stage by stage, so you'll know where they've all come from. I want to start with the waste calculations at the top of the description column here. And we're going to work through these, and then we'll move on to the actual site clearance, which is our first takeoff. So let's have a look at these waste calculations. We've got 3 multiplied by 8 equals 24, and then we've got 8 there. So what does that mean? Well, we are trying to find the distance from this point here to here and to here. That's the overall site dimensions, which we will use for site clearance. So we know we've got dimensions here. We've got 3 8s, and 3 8s are 24. We've got to add on to that the distance from here to here and from here to here. And as the bases are 2 meters, that's half, that's 1. So we need to add on 2 meters to the 24, which gives us a site length of 26 meters. So from here to here is 26 meters. For the width, we've got the same. We've got 8 meters here, and we've got to add on a meter from there to there and a meter from there to there, giving us a total of 10 meters. So our overall site dimensions are 26 by 10. Now, the next set of waste calculations here appertain to the existing ground levels are used for the general excavation item here. So let's have a look and see what we can make of these numbers here. Well, we have 17.65, which is here, this one here. The next one is 18, so we've got that one there. 17.85 is this one here, and 17.6 is this one here. Now we know that the top of our bases is 17.4, so if we just bring up another sheet, this is our section 1, we can see the top of the bases is 17.4. So the level there, as we've just said, is 17.4. So let's just move back to our main drawing. So we, from our existing ground level, we take off 17.4 and another 17.4 for this one, another 17.4 and another 17.4. So at the corner base here, 17.65, the depth down to the top of the bases to excavate to is 0.25. Here it's 0.6, here it's 0.45, and here it's 0.2. But, a very important but, we have to allow for the topsoil, which will also be removed and measured separately. So let's just go back to our drawing here. We have from here, this line here, we have 150 millimeters of topsoil to take off. So let's just go back to our other drawing, our dimension sheet. So we then take off the 150 millimeters, take off there, take off there, take off there. Gives us depths to excavate to the top of the bases of 0.1 for here, 0.45 for here, 0.3 for here, and 0.05 for here from underside of topsoil. Now, the obvious thing to do is to average them out, which we have done, and that gives us an average depth of 0.3. So that's what these waste calculations are for. So next we will go on and have a look at how we properly quantify site clearance. Okay, let's have a close look at Class D, demolition and site clearance. I think this is one of the easiest classes to understand, not just from a practical point of view, but also for understanding the CESMM4 layout a lot easier. So let's start at the beginning. We've got the Class D, demolition and site clearance title. Underneath that we have includes and excludes. Now these are quite important because included in this class is demolition and removal of natural and artificial articles, objects and obstructions which are above the original surface. Now the original surface is defined as the surface of the ground before any construction work starts. That doesn't mean to say it's virgin land. What that means is that the site is as it is, and it may have had some pre-contract work done on it. So, but that doesn't matter. It's the ground the contract is actually going to be built on. The excludes tells us that removal of articles, objects and obstructions, materials other than tree roots at or below the original surface. So this is telling us that demolition and site clearance is an area business. It's not a depth. We're not excavating anything. And it does give some examples of where some of the stuff below ground may be included. Class C, which is earthworks. I is pipeworks. K is pipeworks. L is pipeworks. R is roads and pavings. T is tunnels. X is miscellaneous. And Y is sewers. So that's where stuff below the ground would be measured. So we've briefly mentioned that the CESMM4 is laid out from left to right. We've got the left-hand page here and the right-hand page here. We split the left-hand page up into a first division, second division and third division, and that's usually in degrees of detail. So there's a general detail in first division. For instance, here we have trees in the first division. In the second division, we give a little bit more detail, girths, 500 millimeters to 2 meters, and so on and so forth, until we get through to the third division. And if we look at buildings and other structures, we have buildings, brickwork, volumes, etc. So it's expanding the detail so that we can have a better understanding of what we're trying to measure and ultimately to try and price. On the right-hand side of the page, we've got more columns. We've got measurement rules, very important. We've got definition rules, coverage rules, and additional description rules. So it may be that there is a requirement to add something to which perhaps is not on the left-hand side of the page. We've also got these horizontal lines here. Now, these horizontal lines run from left to right, so it's no accident that they all tie in. The double horizontal line here means that anything above it, and in this instance C1 coverage rules and A1 additional description rules, apply to everything below it. They run across the page, so in site clearance we've got a horizontal line here and we've got a horizontal line here. So all of these, D1, D2, C2, C3s, A2, 3 and 4, all belong to site clearance between this boundary here. Now there is an exception in that when we look here, A4 seems to be a bit deeper. There's no horizontal line. So A2, A3 and A4 do actually apply for site clearance all the way down to number 3, tree stumps. And that's how CESMM works. I think it's quite easy to follow. It's been around a long time as CESMM. So it's been well used and it hasn't had much criticism and it hasn't changed all that much over the years, so that is good news. So where were we? Right, we've looked at some of the items. Site clearance. Now the general clearance, and this is important, is measured in hectares, so that tells you we're in civil engineering speak and not in domestic property speak, which will be measured in square metres. So unit is hectares, and don't forget the unit is tucked away on the right hand side of the second division. So for general clearance we have some definition rules. So how is it defined? And it says here that D1, general clearance shall include the demolition and removal of all articles, objects and obstruction which are expressly required to be cleared, except for those for which separate items are given as set out in this class. I think that's pretty straightforward. D2 refers to invasive plants, which links in with the second entry in the second division there. But let's move across to coverage rules, and we've got a C1 here above the double horizontal line. C1 states items for demolition and site clearance shall be deemed to include disposal of all the material arising. That's important as well for estimating. It's not just the demolition and clearing, but it also means carting it all off to tip somewhere, and of course that incurs extra costs. So moving down to the underneath the double horizontal line, C2, items for general clearance which include the removal of hedges shall be deemed to include the removal of hedge stumps of any diameter where these are also required to be removed. C3, items for invasive plant species shall include the disposal of any vegetable matter remaining after they've been treated. So there's a time factor there between spraying the invasive plants, probably Japanese knotweed, until they're finally destroyed, but then they have to be disposed of. Over to the right, the additional description rule, A1, item descriptions for work for which materials arising remain the property of the employer shall so state. That is not uncommon. I worked on a project in Leeds. It was a multi-storey building, not a civil engineering project as such, but we had to do some excavating, and part of the excavation revealed cobblestone sets that had been used for old roads in the Victorian times, and the council were quite keen to keep those. So there was an item in that method of measurement at the time to say these materials shall remain the property of the local council as it was, and had to be taken and transported. So there was a cost involved. Below the double horizontal line, we've got item description for general clearance shall include the area included unless it is the total area. It may be, it's a big site, and this particular part of it is only part of the site, and so that would have to be declared. Item descriptions for invasive plant species shall state the method of treatment and the type of vegetation, herbicidal chemicals. And A4, where holes left by stumps removal are to be backfilled, item descriptions for general clearance, trees and stumps shall state the nature of the backfilling, type 2 backfill or something of that nature. Okay, let's whiz across to the left-hand side of the page. We're on item 2 now. We've got trees. The unit is number, 1, 2, 3, 4. The girth, 500 to 2 metres in. Moving across the page, girths of trees shall be measured 1 metre above the ground. It doesn't have to be 1 metre, it just is 1 metre. So we measure it with our tape measure, and then we measure around the tree trunk, and that tells us what the girth range is going to be. C4, state items for clearance of trees shall be deemed to include the removal of the stumps where they are also required to be removed. And in most cases on civil engineering projects, you'll be taking out the stumps as well. Now then we move on to item 4 in the first division, buildings. It's quite possible that we have buildings to demolish, and that is a sum. It's a sum of money. We don't measure the building, we don't quantify it apart from its volume, and let's see how we do that. But we do have to state the predominant material is of that building in the second division. Brickwork or concrete, masonry, metal, timber, or no predominant material. The way it's quantified at its size is a volume. and volumes start at not exceeding 50 cubic meters and run right the way up to 2,500 to 5,000, and then stated exceeding 5,000 for the absolute largest volume. Moving across the page to definition rules, it says the volume used in the classification of buildings and other structures shall be their approximate volume occupied, excluding any volume below the original surface. So we don't take into account any basements, but we measure the box, if you like, that the building would fit in. So it doesn't have to be precise, but clearly it has to be accurate enough. Over on A5, we have buildings and other structures shall be identified in the item descriptions. On other structures, again, brickwork down to timber, volume is the same, and again, A5 would apply. And lastly, Class D, we have pipelines, number 6, it's measured in meters, that's linear meters, and we define it by its nominal bore, that's the internal diameter, the pipe itself, between 100 and 300, 300 to 500, or exceeding 500. Then over in the right hand side of the page under measurement rule, the M1, the first rule, is pipelines within buildings and other structures shall be measured only where their nominal bore exceeds 300. Effectively, we're ruling out plumbing pipes. They are just pulled out along with the demolition of the building. But anything larger than 300 often requires a little bit more specialism to take it out of an existing building. There may be brackets and hangers. Coverage rules, C5, items for demolition of pipelines shall be deemed to include demolition and removal of their supports. In commercial buildings, you will get hangers on the outside of the buildings carrying pipes, same on the inside, and there may be special structures to hold pipes. All of that has got to be included in the demolition. Okay, that's a brief explanation of classification D, demolition and site clearance. But what I want to show you now is just a short video of an actual site which has lots and lots of stuff on it, just to give you sort of a visual idea of what we've been talking about. So we'll move over to Google Earth and have a look at a real site. Let's take a look at this location on Google. It's the proposed site for demolition and site clearance. It's quite amazing what we can do with Google Earth, which is what we're looking at now. We can measure and slip into 3D mode. So let's have a look at this site and see what could be involved with a site clearance under Civil Engineering Standard Method of Measurement number 4. Well, the first thing we need to do is to plot our site. So we'll click on this one here and we'll go for a polygon. Let's move it out of the way, and then we'll click our first point, and then we'll click our other point. We'll assume it's up here somewhere, down here, down to the road, down to the junction, and down to the crossroads here, and back to the starting point. And if we look at our little box here, we can see that we have an area of 1.76 hectares, and we haven't done any topographics survey ourselves. We've had no drones, we've just used Google Earth. Clearly there could be some accuracy issues, but it's a good starting point. The next thing to do is to have a look and see what we might have to clear for Class D demolition and site clearance. So let's have a look. Well, let's just sort of slip into 3D mode, which I think we can do by just rolling the mouse backwards here, and we can see we've got quite an array of bits and pieces to clear. We've got some old tyres here, a metal shed, another shed, a brick building looks like it there, another metal shed, some tanks here, a metal shed here, maybe some buildings here, and we've got a proper building here as well. Over here we've got, looks like a tip, to be honest. It looks like all sorts of bits and pieces. So from Class D we've got site clearance, general clearance in hectares. We know now, we've got the size. We've got trees to clear, we've got tree stumps to clear, we've got buildings to clear, we've got other structures to clear, such as these things here, and we've probably got pipelines somewhere, probably down here somewhere. So this probably encapsulates most of what is in Class D, and it does give you a visual idea of the sorts of things that you would have to clear. Now, someone looking at this, estimator looking at this from a pricing point of view, would have a pretty good idea as to the cost of clearing all this site once the boundaries have been sort of officially recognised and accepted. So a good starting point for site clearance, for a visual, is to look at Google Earth. Now that we have understood the practicalities of site clearance, we can move back to our dim sheet. We've got all the waste calculations done for DIMS, for site clearance, general excavation with topsoil, general excavation for other than topsoil. So let's see where we stand. Well, our first entry is a description which is site clearance, general clearance, and there's a reference D1.1.0. We'll check that out later. But then we've got some funny numbers here, 0.03 and 0.03. So what does that mean? Well, remember that site clearance, the units are in hectares. So we need to convert square meters to hectares, and we measured in meters. So we know that our length, 24 meters, plus the extra bits at the end here and here, is equal to 26. So that's 26 meters from there to there. And similarly, for the width, we've got 10 meters. So it's 8 plus 1 plus 1 gives 10. So that's 10 meters from there down to there. So if we multiply that out, so let's just bring in a calculator. So we've got 26 times 10 equals 260 square meters. Now we need to convert that into hectares. So we divide by 10,000. And that gives us 0.026. So we round that up and we get 0.03. So that's where that comes from. Now the next set of descriptions and dimensions is the general excavation for topsoil. We've got a not exceeding 250 millimeters deep. And again, we've got our dimensions that we've previously calculated, 26 by 10. And this time the depth is 0.15, as this is the depth we have been told to use. Multiply all that out and we get 39.00 as the cubic meters of topsoil to be removed. A description, general excavation topsoil, we'll check that out later to see whether it complies with CESMM. And then the next one down here is general excavation of material other than topsoil. So again, we've got our length and our width, and this time we've got 0.03. So where has that come from? Well, let's just revisit these waste calculations. We started off by looking at the existing ground levels at the top of the bases, 17.65, 18, 18.85 and 17.6. We took away the level of the top side of the bases. That was 17.4, 17.4, 17.4 and 17.4. And that gave us a figure. Then we took away the topsoil because that was measured separately of 150 millimeters, and we got depths from the underside of topsoil to the top of the bases of 0.1, 0.45, 0.3, 0.05. Average that lot out and you get 0.3 meters. So that's where the 0.3 meters come from. Multiplying it all out, we get 78.00 cubic meters for general excavation material other than topsoil or artificial hard material within a depth band of 0.25 to 0.5 meters. Excavated surface, top of all bases, and a reference E.4.2.2. So let's now check out the method of measurement and see whether these descriptions stacks up. I've dropped in the Class D page 30 to the bottom of the screen. We can now trace out our description. Class D, site clearance, general clearance, and as we have nothing in D1 or A2, we can be confident our description complies with CESMM4 and our code D.1.1.0 is valid. Our next set of DIMs uses Class E Earthworks, which we haven't looked at in detail, but the methodology is exactly the same to derive a valid description. We have the includes and excludes at the top of the page, and from the first division we can only choose general excavation. Then topsoil from the second division with a depth bound of not exceeding 0.25 metres, as our topsoil is stated as being only 150 millimetres or 0.15 metres thick. We have nothing for the right hand side of the page, so our description qualifies and its code of E.4.1.1 is valid. We need to do some more waste calculations for excavation of the bases and beams. What we are trying to achieve is the depths to excavate to for the corner bases, intermediate bases and the beams. So let's see how it works out. I've attached the section 1 drawing so it's easy to relate to the dimensions. Now first of all we've split the waste calculations into two columns here. We've got the corner bases and we've got the bases intermediates down here. Now we know the top level of the bases is 17.4, and if we look across here we could see that top of bases 17.4, so this is that level there. We know the underside of the corner bases is actually here. The underside of the corner bases is 16.00, and that gives us a difference of 1.4 metres. So from here to here is 1.4 metres. So let's move over to the intermediate bases, and we can see in this cross section there is one here. The top level is still the same, 17.4, but the underside of the intermediate beams is 16.2. So what we need to do here is to take away 16.2, and that gives us a depth of 1.2 metres. So that's from there to there. So far so good. Let's move on to the ground beams. So the top level of the ground beams is also 17.4. So we can look here, we can see these ground beams here, and the top level is the same as the top of the bases, 17.4. The underside of the ground beams here, like this line here, is 16.95. So if we take off 16.95 from 17.4, we get 0.45, so that's 0.45 to down to there. Now we have to take into account blinding, and blinding is a layer of very weak concrete that is spread at the bottom of an excavation at the proper base level to make it easier to construct the formwork and the steel reinforcing. So let's have a look at these numbers again. So let's take the corner base as 1.4, so that's that one there. We'll take the intermediate base as depth, that's that one there, and we'll take the ground beams depth, which is that one there. If we add on the 75mm blinding, which we've got to do because we've got to dig slightly deeper so that we can get the 75mm blinding layer, is exactly the underside of the beams and the bases. So we're adding on 75mm, so we've got 1.475 there, and we've got 1.275 there, and we've got 0.525 there. So I'll explain the blinding activity to you so you'll understand more where the dimensions come from. This sketch shows a typical base and column in an excavation. From a measurement perspective, we measure topsoil removal first and assume 150mm, as it's impossible to be super accurate. This is Class D, general excavation topsoil. Next, we have excavation from the underside of topsoil to the top of the bases. So we have again general excavation material other than topsoil because it's overall the site. Then we come to the actual individual base foundation excavations from top of base level to the underside of bases, plus the additional depth of 75mm for the blinding. Looking at the sketch, we can see there is a lot more excavated volume than the calculated volume, but that doesn't matter. The contractor, when pricing the Bill of Quantities, will take all this into account to allow for all the additional space to get into the excavation to construct it, rebar, formwork and so on. Very importantly, the blinding layer level must be equal to the underside of bases layer level. So although the actual depth of blinding will vary because the excavation base itself will not be that level, it's the top level that must be accurately set to within normal setting out accuracy. Okay, let's see if we can complete the first page of the dimensions. It would seem that we have all the necessary waste calculations, so let's get going and see how far we can get. Right, we're now down at the bottom of the description column here. We've done site clearance, we've done topsoil removal, we've done general excavation, so now we need to measure the bases and the beams. So we've got corner bases, 2 by 2 by 1.48. So where does the 1.48 come from? Well, remember these waste calculations here. 1.475 rounded up gives us a 1.48. Multiply it all out gives us 23.68, and that's excavation for found material other than topsoil, rock or artificial hard material. Maximum depth 1 to 2 meters, so it fits in with the 1 to 2 meter depth band. Commencing surface oversight excavation. So that's our corner bases. These are our intermediate bases. We've got 4 of those, 2 by 2 by 1.28. Where does that come from? It comes from here, from our waste calculations of 1.275 rounded up gives us 1.28. And there are 4 of them, and that gives us 20.48. Add them all together and we get a cubic meter volume of 44.16. We have a CESMM code here, E.3.2.4, so we'll check that one out later. Right, let's move to the top of the right-hand side of the dimension sheet, and we've got our ground beams. We know they're 6 meters long. If you look at this drawing here on the left, we know the center to center is 8. We know the bases are 2, so this is 1 meter. Take that away from 8, it gives us 6. There are 10 bases. We know they're 0.5 meters wide, and we know the depth is 0.53. So again, where does that come from? From this waste calculation here, 0.525 rounded up gives us 0.53. And that gives us a volume of 15.90. And that's excavation for founds, material other than topsoil, rock or artificial hard material. Maximum depth 0.5 to 1. Yes, it fits in with that category there. Commencing surface oversight excavation, and the CESMM code is E.3.2.3. We then move on to excavation ancillaries, and this is for disposing of all the excavated material that we have measured. And the first disposal will be the topsoil, the second will be general excavation, the next one will be the corner bases, the next the interior bases, and finally the beams. So that's what that means. The material that we take out of the ground has to be disposed of somehow, and it's a measurable item, so that's what we're going to do. The realities are that we could probably sell the topsoil if it was not going to be used on our site. That's not uncommon on contracting, and especially in civil engineering, where there's not an awful lot of need for extra topsoil, so it can be sold on. So let's have a look at the measurements. Well, the site dimensions are here, 26 by 10, and it is topsoil, and we know that that's 150 millimeters, so that's 0.15. That gives us 39.00 cubic meters of topsoil. Now, these dims here are exactly the same as the excavation ones. So 26 by 10 by 0.15, 26 by 10 by 0.15. Same here, 26 by 10 by 0.3, so that was our average depth. Where do we get that? That's here. So that comes to 78, so it's the same dimensions here, 26 by 10 by 0.3, 26 by 10 by 0.3 for general excavation. There are 4 corner bases, 2 by 2 by 1.48, 2 by 2 by 1.48, giving us 23.68. There are 4 inner bases, 2 by 2 by 1.28, 2 by 2 by 1.28 gives us 20.48, 20.48 the same. And then finally the beams, there are 10 of them, 6 by half a metre width by 0.53 in depth. Here we've got it again, 6 by 0.5 by 0.53, and that gives us 15.9. And here we've got it again, 15.9. Add all that lot up and we have a total disposal of 177.06 cubic metres. Excavation ancillaries caters for activities that can be done to excavated surfaces. So we need to visit CESMM page 34 to find out what it's all about. Trimming of excavated surfaces and preparation of excavated surfaces can be found on page 34 of Class E under item 5, excavation ancillaries. So in the second division we've got trimming of excavated surfaces, and that's square metre, and that it can apply to topsoil, material other than rock, stated artificial hard material, or controlled and hazardous material. Underneath, in the second division, we've got preparation of excavated surfaces, again in square metres and applicable to items 1 to 5 in the third division. It's not overly clear what activities are meant to be for trimming and preparation, but let's move on to the measurement rules and see if we can shine any light on it. Rule M10, trimming of excavated surfaces shall be measured to surfaces which are to receive no permanent works. So we've done the excavation, we're not putting anything else on top of it, and that's it, it's just trimmed. And that just might be a light touch in terms of actual work, smoothing things out, making things look generally tidy. Moving down to M11, we're on preparation of excavated surfaces shall be measured to surfaces which are to receive the permanent works, whether preparation is expressly required or not. So it doesn't matter in both cases, it's still an area and it's still measured. So preparation is to surfaces which are to receive the permanent works, and I guess there that might require more work, except surfaces which are to receive filling or landscaping and surfaces for which formwork. So that's the exceptions. I think a preamble paragraph should or could explain further what exactly the client means by, or the extent of trimming and preparation. But nonetheless, this is what the measurement says. We have to measure it whether it's expressly required or not. So trimming is for where there is no permanent works to be put on top of it, and M11 is preparation of surfaces where there is the permanent works to be put on it. Back to our DIM page, now that we know what trim and prep are all about, let's see what we have to measure. Firstly, trim and prep are areas. So our areas to prep, i.e. areas to receive the permanent works, are the underside areas of the bases and beams, which will receive the concrete for them. Our DIMs, therefore, will be 2 lots of 4, 1, 2, 3, 4, 1 lot, 1, 2, 3, 4. So that's 2 lots of 4 bases, each 2x2, which gives us an area of 32.00 square metres. And then we have 10 beams, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 beams at 6 by 0.5, giving us 30.00 square metres. So adding the two together, we get 62.00. And the description is excavation ancillaries, preparation of excavated surfaces. And the CESMM code is E.5.2.2, and we can check that out later as well. For excavated ancillaries trimming, i.e. there is no permanent works to be built on top, we have the site area, 26 by 10, 260 square metres, less 2 by 4 for the bases, 4, and there are 2 of them, 2 by 4 by 2 by 2, giving us 32.00 square metres to deduct, and we have 10 beams at 6 metres and 0.5 metres wide, giving an area of 30.00 again to be deducted. So our total excavation trimming area is 198.00 cubic metres. The code E.5.1.2, again to be verified later. We are now close to finishing with concreting Class F. In CESMM4, concreting is in 2 parts. Provision of concrete, the total amount of a particular grade and aggregate size, and then a second part where it identifies where the concrete is to be placed. It's a recognition that concreting has two cost centres, one for provision, this could be ready mix or more likely the costs of setting up batching plants, quite common for civil engineering projects, and then quite separately the cost of placing concrete in different areas which may well have differing costs. In the BQ, the provision for each type are grouped as one and the placing grouped per structure. On our dim sheet then we have the blinding, and we've got provision of concrete design mix grade C10, 10mm aggregate to BS8500. So we've got our corner bases 2x2 by 0.08. The 0.08 comes from the 75mm of blinding, which when rounded up gives us 0.08. So there are 8 of those and there are 10 beams, 6 by 0.5 again by 0.08, and that gives us a total blinding concrete of 4.96 cubic meters. And then we've added on the placing of that blinding concrete. Down here we've got the bases, we've got corner bases, 2x2 by 1.4, and the 4 inner bases 2x2 by 1.2, so that gives us 22.4 cubic meters, 19.2 cubic meters, a total of 41.6 cubic meters. The description: provision of concrete design mix grade C30, 20mm aggregate to BS8500, and there's a code there F1.1.5.2, and placing. Next we go down to the beams, and we've got 10 beams, 6 by 0.5 meters by 0.45, giving us 13.50. Provision of concrete and design mix a grade C30, 20mm aggregate to BS8500, and the code 5.1.5.2, and placing of the reinforced base footings, thickness 300 to 500. So that completes the concrete, which is quite easy, and all the waste calculations for the depths have been done before. So once we've got over that initial hurdle, waste calculations, then life becomes a lot easier. Right, next we'll talk about formwork. Formwork, which is class G. Formwork, as we know, is the means of creating our base, beams, columns, and it's a mould, so we can pour concrete into it. It can be a bit fiddly to measure, as we have to look carefully at our drawings to make sure we have included all the various vertical surfaces with proper deductions for joints, such as these here. We've got formwork down here, formwork down there, formwork down there, and also across here where the beam is. But the formwork for these corner bases will have some deductions for the beam that comes this way, i.e. it comes out of the screen. So as I said, it's a bit fiddly, but if we take it steady and systematically, it'll work out okay. I've switched views to include the 3D view, as it's easier to show formwork surfaces and the deductions. So our first takeoff is down here. It is formwork, rough finish, that was in the specification, plain vertical, width exceeding 1.22 meters, and I'll explain the importance of the 1.22 later. There are 4 corner bases, 1, 2, 3, 4, and each corner base has 4 sides, 1, 2, 3, and 4. So our first dimensions are 4 for 4 corner bases, 4 sides, 2 meters by 1.4 deep, and that gives us 44.80 square meters. Now we have some deductions as to where the beams join the bases. So if you look here, we have a join here and we have a join there. So each corner base has 2 joins, one there, one there, one there, one there, one there, one there, and one there. And the join is 0.5 meters wide by 0.45 meters deep. There are 2 of them per corner base, and there are 4 corner bases, 4 by 2 by 0.5 by 0.45, which gives us 1.8 square meters to deduct from this figure here, giving us the square meterage of 43.00 square meters. It's got a CESMM code here, G.1.4.5, which we'll verify later. Okay, let's move on to the next one, and we are now talking about the interior bases. 1, 2, 3, 4. There are 4 of those, and each one has 4 sides, and each side is 2 meters long by 1.2 meters deep, so it's slightly shallower than the corner bases. So here we are, 4 intermediate bases, 4 sides, each side 2 meters by 1.2, giving us 38.4 square meters. Formwork, rough finish, plain vertical, width 0.4 to 1.22 meters. Then we have the beams, and we have 10 beams, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 beams. Each beam is 6 meters from there to there, and each beam height is 0.45, so that's from there to there. And there are 10 beams, and there are 2 sides. 10 beams, 2 sides, each side 6 meters by 0.45, and that gives us 54.00 square meters. Now we have some deductions. Each intermediate base has 3 deductions: 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And each deduction is 0.5 meters wide by 0.45 meters deep. So there are 4 intermediate bases, and there are 3 joins, each join 0.5 to 0.45 in depth, giving us 2.7 square meters to deduct from all of this, which gives us 89.70 square meters. And the CESMM code is G.1.4.4, and again we'll verify that later. The reason for the rather odd size range of 0.44 to 1.22 meters is that plywood sheets for construction, or indeed for anything else, are sold in 1.22 meter widths. So it's an indication to the tenderer how many sheets need to be purchased to get the optimum use out of them and keep waste to a minimum. Now, let's check out these descriptions with CESMM itself. Our first takeoff in this exercise was site clearance, general clearance, and the CESMM code was D.1.1.0. The quantity was 0.03 hectares, so let's have a look at Class D and see if this is the case. First division, number 1, site clearance. Second division, number 1, general clearance. The unit is hectares, so the description of site clearance, general clearance, D.1.1.0 is fully in compliance. The next 4 descriptions are to do with excavation. Our first one is excavation of topsoil, and then material other than topsoil, excavation for foundations, excavation for foundations. So let's start at the beginning and see whether these stack up as well. Well, general excavation topsoil is referenced as E.4.1.1. So let's have a look. E.4.1.1. So yes, that one complies. Our next one is general excavation, material other than topsoil, maximum depth 0.25 to 0.5 meters, excavated surface, top of all bases. So let's have a look at this. Right, general excavation, so that's E4. We've got material other than topsoil, so that's E4.2. And then we have the maximum depth, which is item 2, 0.25 to 0.5 meters. So the code is correct. Now, one thing that is slightly different, notice here it says excavated surface, top of all bases. So is that necessary? Well, let's just take a quick flip across to the second page of CESMM and have a look and see what we can find. And we don't have to look far, but looking at the additional description rules, because it is pertaining to a description, it says quite clearly under additional description rules, the commencing surface shall be identified in the description of each item for work involving excavation for which the commencing surface is not the original surface, and similarly, the excavated surface shall be identified in the description of each item for work involving excavation for which the excavated surface is not the final surface. And the first part clearly applies to our measurement. It's not the original surface we start from, it's the underside of topsoil. We have the third one, excavation for foundations, material other than topsoil, rock or artificial hard material. This time the depth band is 1 to 2 meters, whereas that one was 0.25 to 0.5. The code is E.3.2.4, so let's check that out. E.3, excavation for foundations, 2, material other than topsoil, and 4, 1 to 2 meters. So that one checks out nicely. Let's move on to this one here. We've got excavation for foundations, material other than, rock or artificial. A maximum depth 0.5 to 1 meter, commencing surface oversight excavation. So let's have a look at the code. So we've got E.3, excavation for foundations, .2, material other than topsoil, rock or artificial hard material, and then 3, 0.5 to 1 meter. And we've added the additional description A4, commencing surface oversight of excavation. Our next takeoff is excavation ancillaries, disposal of excavated material, and the first one is topsoil, and the code will be E.5.3.1 topsoil. All of the others, general excavation, corner bases, inner bases, and beams, will be grouped together under excavation ancillaries disposal in the Bill of Quantities, and they will share a code of E.5.3.2. Our last two descriptions on the first DIM page are these: excavation ancillaries, preparation of excavated surfaces, and excavation ancillaries, trimming of excavated surfaces, and we've discussed what those are and what entails. So let's have a look and see whether they stack up with the method of measurement. We have a code here of E5.2.2. So E5.2, preparation of excavated surfaces, material other than topsoil. So that's correct. Let's look at the next one. Excavate ancillaries trimming, and it's E5.1.2. So it's E5.1, which is trimming, and 2, material other than topsoil, rock or artificial hard material. So both of those codes and descriptions are compliant with the method of measurement. We now come to the last page of our dimension sheets, and this is where we quantify concrete and formwork. Remember, concrete is measured in 2 parts, provision and placing, recognizing that there could be significant costs in providing, which would include batching plants, etc., and equally differing costs in placing concrete, first floor or second floor, beams, columns and bases. Let's have a look at the first one, which is the provision of the blinding concrete, which is grade C10, 10mm aggregate. So how does that stack up with the method of measurement? Well, the code is F111, so let's have a look. F1, so that's correct, design concrete. Second division, 1 again, strength 8 newtons, and in the third division, 1 again, 10mm aggregate size. So F111 is fully compliant with the method of measurement. Our next one is provision of concrete designed mix grade C30, and the code is F172. So does this description stack up with the method of measurement? Let's have a look. Class F, 1 design concrete, 7 30 newtons, and 2 20mm aggregate. So the description here again is in full compliance. Moving down to this one here is exactly the same. Provision of concrete 30 newtons and the code F172, exactly as that before. So this description here is also fully compliant with the method of measurement. Okay, what we will do now is we'll shift the pages, the method of measurement pages, to look at the placing of concrete. The reason for adding in reference to BS8500 is the additional description rule A1, which requires the specification of concrete in accordance with BS 8500 to be stated in the item description for provision. We now come to the placing of concrete, which is Class F on page 40. The volumes are the same as for provision of concrete, but let's check out to see if our descriptions are compliant. Well, the first one is the blinding, placing of concrete mass blinding, thickness not exceeding 150 millimeters, and the code is F6.1.1. So if that's F6, which is mass, 1 blinding, and thickness not exceeding 150 millimeters. So F6.1.1 is fully compliant. Our next one is for the bases, placing of concrete, reinforced bases, thickness exceeding 500 millimeters. The depths are 140 and 120, so they are exceeding 500 millimeters, and the code is F724. So let's check that one out. F7, reinforced bases, footings, pile caps, and exceeding 500 millimeters. And the last one is for the beams, placing of concrete, reinforced bases, footings, etc., which includes beams. Thickness 300 to 500 millimeters. Our depth of our beam is 450, so that fits neatly into this description. And the code is F723. So F7, reinforced, 2, bases, footings, pile caps, etc. And the next one is 300 to 500 millimeters, which fits the description. So our descriptions for placing and provision of concrete are all compliant with Class F. Next, we will check our formwork Class G descriptions, and then we will commence preparation of our Bill of Quantities. Formwork descriptions are Class G, page 42. We've got 2 of them. We've got formwork, rough finish plain vertical, width exceeding 1.22 meters. These are our bases. So one of our bases is 1.4, so that's greater than 1.2. And our code is G145, so let's check that out. G1, formwork, rough finish, which is what it is. 4, plain vertical, which they are. And 5, exceeding 1.22 meters. So that's valid. The next one is formwork rough finish, plain vertical, but the width is 0.4 to 1.2. Now these are our intermediate bases and beams. The width is 1.2, which fits into that category. And for the beams, 0.45 also fits into 0.4 to 1.2. So the code is G144. Let's have a look. G1, formwork rough finish, 4, plain vertical, and 4 again, 0.4 to 1.2 meters. So the descriptions for formwork are validated by the method of measurement. Let's go and make some bills of quantities. We are now on the home straight, so let's look at our bill of quantities and see where the dimensions and descriptions come from. We've already checked the validity of the description codes, so providing these haven't changed, we should be okay. And that leaves us to check that the dimensions are all properly abstracted from the dim sheets. This can be a long process if we had many dim sheets to abstract from, so it needs careful attention and time to do it well. I will be abstracting in Bill of Quantities code order, so that could be slightly different from the order we quantified our dimensions. Our first entry on the Bill of Quantities is demolition and site clearance, and we've got site clearance, general clearance in hectares, and we've got a quantity of 0.03. So where's that come from? Well, if we go all the way over here, we've got to the left-hand side of the dimension sheet, site clearance, general clearance, D110, 0.03. So that's where the quantity comes from, and the code D110 ties in with the D110 on the Bill of Quantities. The next one down is Earthworks, and we've got a description: excavation for foundations, material other than topsoil, and it's a depth of 0.5 to 1 metre, and rule A4, commencing surface oversight excavation, and we've got 16 cubic meters. If we look over here to the top of the right-hand column of the dimension page, we've got 15.90 excavation for founds, material 0.5 to 1. So the 15.9 is rounded up to 16. The codes tally E323, E323. Moving down, we've got excavation for foundations, material other than, and the depth is 1 to 2 meters. And rule A4, commencing surface oversight excavation, and we've got 45 cubic meters. So where does that come from? Well, let's go right the way down to the bottom of the left-hand column of the dimension sheet, and we've got 44.16 cubic meters, excavation for founds, material other than, maximum depth 1 to 2 meters with a code E324. So E324 matches the code on the Bill of Quantities. Moving down, we've got general excavation topsoil, and we've got a unit of 39 cubic meters. So where does that come from? Well, let's go across to the left-hand side of the dimension sheet. Second item down, general excavation topsoil, not exceeding 0.25, and we've got 39. No rounding up or rounding down. That's just as it is. The next one is general excavation, 0.25 to 0.5, and rule A4, excavate at surface, top of all bases. And we've got 78 cubic meters. So where does that come from? Well, again, let's go back to the left-hand column of the dimension sheet. We can see we've got 78 cubic meters. General excavation, material other than, depth 0.25 to 0.5. And we've got a code here of 422. So the code here, 422, matches. Now, we then move to excavation ancillaries. And the entry below that one is disposal of excavated material with topsoil. So the quantities are exactly the same. So we've got a quantity of 39, but where does it come from on the dimension sheet? Well, let's move up to the right-hand column, second quantity down, and we've got 39 cubic meters for topsoil, excavation ancillaries, disposal of excavated material, E531. And if we look down here, we've got a code of 531 also. The next one down in disposal is of excavated material other than topsoil. And we've got a figure of 139 cubic meters. But where does that come from? Not quite so straightforward, but let's have a look. Let's move over to the right-hand column of the dimension sheet, and let's look at the total of disposals, and it was 177. But we measured separately the topsoil. So if we add together general excavation, corner bases, inner bases and beams, we do get the 139 cubic meters of disposal. Moving down, we've got preparation now of excavated surfaces, and we've got 62 square meters. Where does that come from? Well, let's move across to the right-hand column of the dimension sheet, and we've got excavation, ancillaries, preparation, 62 square meters. So that's where that comes from. And the code tallies 522, 522. Moving down, we've got trimming, and we've got 198 square meters. The code is 512. And where does that come from? Again, the bottom of the right-hand column of the dimension page, we've got 198. Excavation ancillaries, trimming of excavated surfaces, code E512. So that's all we can do from dimension page, the first one. So we'll flip over to the second dimension page and complete the bill for in-situ concrete. Our next main heading on the Bill of Quantities is in-situ concrete, followed by the provision of concrete. Our first entry is designed concrete C810 10mm aggregate to BS8500, and we've got 5 cubic meters and a code of F111. So where does that come from? Well, let's move to the first column of our dim sheet, and we have provision of concrete design mix C10 10mm aggregate F111, and we've got 4.96 cubic meters. So we round that up, and that will give us 5 cubic meters. Our next entry is for C30 20mm aggregate to BS8500. The code is F172 and the quantity is 56 cubic meters. So where does that come from? Well, let's move over to the left-hand column of the dimension sheet and we can see we've got a provision of concrete here, the C30, and we've got a quantity of 41.6. But further down, we've also got the beams, and there were 10 beams, and that gave us 13.5 extra cubic meters. So add the two together and we get 55.10. Round that up and we get 56 cubic meters of C30 37 20mm aggregate to BS550 concrete. Our last BQ, page number 2, and we have placing of concrete followed by formwork. And our first entry on the Bill of Quantities is F611, mass blinding, thickness not exceeding 150 millimeters, and we've got a volume of 5 cubic meters. So where does that come from? Well, let's move across to the top of the left-hand column of the dimension page, and we can see we've got a quantity of 4.96, and we've got the description: placing of concrete, mass blinding, thickness not exceeding 150, and we've got the code F611, so that tallies. The next one is reinforced footings, placing of concrete reinforced footings, thickness 300 to 500 millimeters, a code of F723, and we've got a volume of 14 cubic meters. So where does that come from? Well, let's move all the way down to nearly to the bottom of the first column of the dimension sheet, and we've got the placing of concrete reinforced bases, footings, thickness 300 to 500, and we've got a volume of 13.50, rounded up gives us 14, and the code F723. F723 tallies, so that is okay. The next one is reinforced bases exceeding 500 millimeters, and we've got 42 cubic meters. So where does that come from? Well, we go across here to the middle of the left-hand column of the dimension page, and we've got a volume of 41.6, and the description is placing of concrete reinforced bases, thickness exceeding 500 millimeters, and the code is 5724, and we've got a code over here at 5724, so that matches perfectly. We then move down to concrete ancillaries, and this is for formwork, and our formwork is rough finish, so the entry is formwork rough finish, and our first quantity is 90 square meters, and we've got a code of G144. So where does that come from on the dim sheets? Well, we go up to the top of the second column on the dim sheet, and we've got formwork rough finish plain vertical width 0.4 to 1.22 meters and a quantity of 89.7. We round that up to 90, and that gives us our final quantity, and the code G144 matches the dimension code G144. The next entry is vertical width exceeding 1.22 meters, and we've got 43 square meters and a code of G145. So where do we find that? Well, we find that down at the bottom of the first column of the dimension sheet, and we've got a quantity of 43, and we've got a code of G145, and the description: formwork rough finish plain vertical width exceeding 1.22 meters. So the codes match and the descriptions are compliant. And that's it for taking off and BQ production for a civil engineering structure under Civil Engineering Standard Method of Measurement number 4. A few takeaways from this training video. 1. Civil engineering structures can be quite complex, so give yourself plenty of time. 2. Obtain a 3D view if possible. 3. Pay careful attention to levels so you know where you are measuring from and to. 4. CESMM4 is, in my opinion, a very good and robust document. Take time to learn how it works and you should have no major problems. Thanks for watching.